This video is down at Windy's cellar, and we're going to try to show the construction of a tune pipe fuselage, something that'll probably be popular in the years to come due to Billy Werwich's fine showing at the team trials in the Nats. Anybody who is watching this video and hasn't seen the Nobler construction video, that should be the first thing you should do, is get a hold of a copy of that from Ken. Check that whole thing out. There's an awful lot of construction tips on that. Video was made right in the same shop. You can just pan around the shop, give you an idea of what kind of environment we're going to be working in. I'm going to try to show most or all of the steps of building this. This will be the plane that I'll try to compete with in 1990. Probably try to take it to the Nats. I'm the alternate for the team, so let's assume none of the guys are going to die or get AIDS or something, and I'm not going to go. So if I do, I should have a ship ready to go for the European style of flying, and that's what I'm going to try to build this with this in mind for the World Championships, the team trials, the European style of airplane. Now, anybody that hasn't seen the Nobler construction video, just go over a few things here. I've laid out some of the wood I'm going to use. The first thing I do when I design up a plane is I make a little sketch, and this is the sketch I've made with the basic shapes, not necessarily the paint job, shapes and sizes of what I want. Basically using last year's information and updating it. Every year I take the plane I had the year before and make the modifications to get the vertical CG right and the moment arms, and take into account the nose weight, the amount of paint on the plane. This year's plane is basically going to be a copy of the Mustang with a little bit yeah, sure, he's not drunk, with a modified wing, a little bit smaller tail. We're going to try to downsize the whole plane a little bit. It's going to have a 58-inch span instead of a 60-inch span. We're thinning out the airfoil a little bit, shortening the nose a little bit. Going to try to make a real light tail. Instead of 16 sheet, we'll use 32nd. And step one, which I've already done, I've already got started, is I've made up plywood templates for the parts, the fuse sides, the doublers, and the bulkheads. And I'm going to start tracing them out. I've got one already started here. And there's the plywood template. Now, I have a plywood template for every airplane I've ever built somewhere in inventory. In that desk there's hundreds of plywood templates, so that I can tell from year to year exactly what it is I've changed, how high I've raised the motor or lowered it, length of the tail moment arms, airfoil shapes, and the general weight and the performance of the planes. So all of these planes become really, the further on to the development they get, they should get better and better, and theoretically they should get really good toward the end. This one is at the end of about 5 that I've made, and I'm hoping this is really going to be a good one. I'm going to try to develop, and the reason this video will be different than the Nobler one is this fuselage will have a radial mount, rubber mounted engine, side mounted, and a little bit different construction here and there. The wheels will be in the wing to allow extra room for the pipe. And I'm going to try to incorporate a real slick looking cowling and canopy setup, which I'll try to get on the video. So step one always is to get a set of plans to work from, and my suggestion is get a set of proven plans. Don't, if you're not familiar with designing, get something that you know works good. Any of the Werwich planes, Bobby Hunt plane, Jim Greenaway's planes, just to name a few, or copy right off a Nobler. And I guess you can see in the shop, I never get too far from the Nobler plans. They're hanging right up on the wall, right behind the Red Baron pizza decal there. Constantly like to go back to the Nobler from time to time and see. If you're pretty close to a Nobler, you're going to have a pretty good flying ship. Other than that, once you get your plans, I suggest making up plywood templates for everything out of 16 plywood, so that from that point on you can duplicate that plane in a matter of minutes, really. You can just cut out the parts and make an exact duplicate of it. You'll never have one where the motor is a little higher than the wing, or the wing is higher because you copied it wrong. Once you got that plywood, you've got things pretty well under control. So I'll get on with the next step of this, and we'll try to get some of this on video. And one of the things I always have is I always start, of course, with decent quality wood. Try to sight down the edge and make sure everything's nice and straight. I've laid out the formers where I intend them to be and everything on this piece of 16th plywood. Now when I go to build next year's plane, if the vertical CG was wrong, well, I would know exactly where this year's was and I could adjust it accordingly. If I know the plane came out nose heavy, I could shorten the nose a little. If the plane came out tail heavy, I could be real fussy about what I put in the back of the plane. I'm basically building this plane off of the Red Baron, even though this is not going to look like the Red Baron in any way. It'll have all the moment arms and things that the Red Baron had. I got a glass table here. I try to use the glass table for cutting on, getting all my parts straight. One of the things that's real important is when you're making fuselage sides, try to get nice straight wood. Don't necessarily go for the lightest piece of wood. Now, of the wood I selected, I have about 150 sheets of 1/8" wood. I did not select the two lightest ones by any means. I selected, first choice would be if you could get sea-grain wood. Sea-grain would be choice 1. But choice 2, right behind that, would be to have wood that's really straight and is not going to warp and twist on you the minute you hit it with dope, because that fuselage must stay straight if you're going to have a good chance at trimming this plane out. Now what I've done is I've trued this edge up. This edge on the table is nice and true. The bottom has a 1/2" upsweep in it. Anybody who doesn't know what upsweep is, the upsweep is the amount that the back of the body tapers up. If you were to make this a straight line to the top, that plane will always look like it's flying with its ass end down. You must have some taper up. Now I've decided that about a 1/2" is right on this size airplane to make it look like it's flying level. That's an amount that I've learned to be comfortable with. And what I do is I have a piece of sandpaper here on the table. I just brush that across, get it nice and true. And I try to true up with a sanding block along the edge of my glass table. True up this side of it. I've already cut out the plywood doubler, the equivalent plywood doubler for this. Okay, so we're pretty much ready to go here. This is a piece of sanding belt from a belt sander you can buy in Sears Roebuck. It's glued to a flat glass table with contact cement. What this allows me to do is get a nice straight edge on the fuse side before I start cutting it out and laying out center lines. And a good way to check is just press down in the middle on a flat table. This side is not really too straight. You're really not going to find too many of these pieces of wood that come from any of the bulk companies that are too straight. Also is always subject to moisture, and where we're building here in a really damp area. I got water problems in this basement. Very seldom get where you don't have a problem. If you press down in the middle, that'll allow you to find out how good or bad this is. And when I want to make a final check on this, what I do is I lay out a piece of Delrin that's dead straight. It's machined out on a mill. And I can tell I've got a perfectly straight surface there. That one's not too bad, but it's not perfect either. This just allows me to get a nice fuselage side shape, a straight line to start with, and that's important. Okay, that's my straight side right there. You can buy those sanding belts in Sears Roebuck. It's nice if you have a rough one and a smooth one. Glue them right down to your table in a spot you're not building. You can use that to true up your wood. Nice handy thing to have. What I did, I have my straight edge here now, and I'm just going to true this off with a sanding block. I traced out the plywood template onto the good wood. This is a real nice straight piece of 1/8 inch by 4 by 48, so I won't even have a joint in the body side. Okay, I put a brand new X-Acto blade in the knife. I try to cut all the straight edges first. Try to line myself up on all the straight edges. Every year that I've made these videos, this is the 3rd year in a row, while I'm talking on the camera or trying to concentrate on something, I wind up cutting myself, and this year's no exception. Just took a nice chunk out of the end of my finger, because I was looking at the video camera. So don't feel bad if you cut yourself, you're in good company. I like to use a straight edge and a brand new X-Acto knife. I only get about 1 part per blade before I change the blade. And I don't pull those hairs and ratty edges. I save all the scraps also. This piece is no exception. I'll put that up in a scrap pile. I try to get all my 90-degree angles done with a tri-square, something you should be using on a regular basis. If you keep the X-Acto knife real sharp, you'll probably be real happy with the way the cuts come out. Once you let the blade get a little dull, and remember we're trying to work off center lines, and the first center line for any airplane, I don't care what design it is going to be the joint between the fuse side and the top block. That's the center line from which every other thing is measured. I think the Nobler videos go into that pretty good, give you a good idea of how to pick up some of that technology. Like I said, if you're using a proven design, you probably won't have to fool around too much changing things. Say, for instance, if you're building an Aries or a Nobler or a Pattern Master or whatever, you're probably going to hit it pretty close on the first shot. If you're designing something on your own, you might be off, and you'd like to allow as many options as possible to make the corrections. Okay, that's one fuse side. I'm going to true this up. As I go along, I try to true everything up, so I've got all 90-degree glue joints. Now, I particularly like to work with wood, so my real job of working in a machine shop, I work with aluminum most of the time, and I really don't have a lot of love for working with aluminum, but working with wood is really pleasant. You can really learn to like working with, especially balsa wood. Okay, we've got one fuse side completely cut out, and now what we're going to basically do is duplicate this. We're done with our plywood template temporarily. Want to find this side, the truest side on this piece of wood. That's not it. This is a lot closer, so we'll do this one. Just take a piece of 3-inch wood and use one edge without truing it up, you're probably going to have a twisted body. It's not going to be real accurate. I guess there's an old trick everybody knows about that's ever built planes, is you always wind up building 2 right fuselage sides or 2 left sides. I've probably done that about 15 times already. I used to save them, but I don't save them no more. I was running out of room. Too embarrassing when people come over the house and you show them a lot of duplicate fuse sides that you have. That's a good way to check. Oh, that's a nice one. That's a good way to check that you're getting nice true edges if you can't see light between the joint. Run it up on the piece of Delrin to check for straightness. Still could have a little bit out the middle. Those sanding belts are a really good trick. That's something you don't want to let slip by you if you're doing fuselage sides. Job one on all of this stuff is to try to get everything parallel, the wing cut out, the motor line up, everything parallel to that top edge of the body. When you get that parallel, pretty much that plane's going to fly good. I'm guessing 90% of the headaches of trimming it are out of there then. Okay. looks good. That looks real good, in fact. Maybe we're lucking out on this guy for a change. Now, a lot of people build a plane, they just stick it together and sand it out when it's done. I sand the inside of the plane, the outside of the plane. I try to keep it neat and workmanlike every step of the way. And that just makes it more pleasant to work on. If you ever look inside one of my planes, usually they're nicely sanded inside too, as well as the outside. And it just makes you feel better about putting this amount of work. I put a tremendous amount of time and work into this, and I like to feel good about what I'm doing. That side's no good. This side's perfect. This will be the good side. Okay, so we'll just trace this guy out, duplicate it, and we'll have two exactly the same. I've got the master pattern I started with, and I've got the plywood template. So I've got everything now. If I want to duplicate this plane next year, or if I want to make 2 this year or 3, I can make them in a matter of 10 or 15 minutes, have the exact fuselage side cut right out. I've got our 2 fuselage sides cut out. We've got the 2 plywood doublets. All I want to do before we glue the doublets on is make sure these 2 fuselage sides are really exactly alike, an exact mirror image. It's a lot easier to do it now than once you get involved in this, and the way I can do this now is with a sanding block. Holding them together, I can get the bottoms parallel. Bottom is not a real important thing. It's the top, because we're going to use that line for reference. So we don't want these fuselage sides off by even the smallest amount is going to make it a lopsided operation. It'll be difficult to line up the tail, get the bottom block on nice and straight. And since this is a tuned pipe plane, the bottom of the plane is in some way going to come off. Now I've built 3 tuned pipe planes already. Richie Tower and I worked on a little bit of a development program years ago. We made 2 planes, one of which flew at the 87 knots and got 3rd. With a 60 in it, because we didn't have the technology, we didn't have the carbon pipes that Bob Hunt is manufacturing now. And it was a little bit too heavy with all the aluminum hardware. But now that we have carbon pipes and we have real lightweight headers and good motors and things, this is one of the options you'll have if you build a sunship. Not necessarily the only option, and I'm sure there's still going to be a lot of good running 60s around. But this is something that I've played with for years, and I'd sure like to get one good pliable model, which I hope this one will be. Now this one will have rubber mounts and a side-mounted engine. The idea being that the Schnurley will probably run better on its side than straight up and down, and we don't know that for a fact yet, although Billy has had good luck with that. We'll try to make the most of his technology that he's handed over to us. He's going to Europe next year, so if he becomes the next world champion, we may see hundreds of these flying. I think you're going to see a lot of them flying even if he doesn't win. Okay, getting them sides even is real important. That's a real important part of getting a good fuselage. And I mean not within 1/8 of an inch, I mean real accurate, even the back piece. Okay, we should have no trouble referencing these 2 off now. Okay, what we've got now is 2 matched fuselage sides, and they should be matched real close. I'll vacuum up some of this dust before we actually try to glue the doublers on. Real good idea to vacuum this up as you go, because breathing this stuff in is really not too good for you. And I know I've got all kind of problems breathing and nasal problems from breathing this in for years. Makes working a lot nicer too. When you do this 12-15 hours a day, Just making the job pleasant is a big important thing. I'm sanding these sides inside and out real smooth with 400. The yellow sandpaper, the 3M, is real good for this. I want to get a perfect finish before I glue on the plywood doublers. Then once I get on the doublers, I want to get a perfect center line on both sides of the fuselage. Both sides of both fuselage sides, and make sure that these suckers are accurate. I've timed out what it takes to build an average plane, and building the complete woodwork on a plane is, for me anyway, under the conditions and with the kind of quality checks I make, is about 100 hours. Maybe it's 90, maybe it's 110, but I hope to have this whole plane done in 100 hours and then start on a real exotic European type paint job with a lot of different colors. It seems like the Chinese and the Russians have glitzed up everything. They don't really go for the classic look. They want to see some stars and stripes in 24, 25 different colors, so we're going to try to give them what they like. But hope anybody that watches this keeps in mind that I'm more along the classic lines of Ski Dombrowski and Jim Silhavy. I really don't like the glitz look, but it seems like glitz is what's in this year. And as the team alternate, I got to be ready to glitz them if I have to. Old Jimmy gets married and can't go. Casal, there must be somebody out there you can marry. Okay, both of these are ready now to glue the plywood doublers on, and the important part now is not to glue and make two right sides or two left sides. Make sure you get one left and one right. We're going to use slow drying epoxy, and while the epoxy is drying, I'm going to pull a motor out of the 86 plane to line up all my bulkheads. I like to glue the doublers on with epoxy all the time. I don't like to use anything but epoxy. Epoxy is the way to go. And what's a good idea if you have a shop vac is just get a giant hose. You can get these hose kits for about $14, and you can be vacuuming up every time you do something. Makes it real nice. Okay, we have two fuselage sides. I want to make sure I don't get two lefts or two rights. That's probably what I'm going to do. Okay, make sure I got that lined up. Kind of get all the dust off. That's what my wife likes about doing the laundry. She loves getting this balsa dust off. Now I lay these out and mark each one so I don't make two lefts and two rights. If I do this on camera, I know you guys are really going to have a ball laughing at me too, so try to keep this lined up nice. Okay, that's one. Again, what we're looking for is two exactly the same, and most of all parallel on that top edge. And the way we're going to line that top up is we're going to take our piece of, this is a piece of machine Delrin that has a very accurate edge on one side, and I'm going to use that to line up that edge as I let the glue set, put weights on it. I'll take this apart, put X's on it to indicate that's where the glue goes. And if you go out and make two fuselage sides the same, don't say I didn't warn you, and don't say I never did it, because I've done it. In fact, there was a year Glenn Metter and myself had a contest to see if anybody could make a fuselage without making two fuse sides, and we both lost. Okay, we're about ready. We'll get all the dust off. We'll mix up some slow drying epoxy and get that glued up. Now this is 1 hour epoxy. This is the kind where one tube is bigger than the other. The advantage of using this epoxy, it sets in about an hour. The big advantage of it is it never gets glass hard and brittle. So no matter what kind of vibration you anticipate using or the life of the plane, all the doublers I've ever done with this, I've never had a doubler delaminate even in a crash. So I'm real happy about using this, real satisfied with the results. Now what I do is I take a little spreader. These are the spreaders you can get from SIG or from anybody. You don't have to work too fast. This just doesn't dry too fast. Try to spread on a nice amount. You know you're going to wind up with epoxy on your hands when you get involved in this kind of a job. Let's see if I got another spreader. That one's kind of shot. If you don't have a spreader, a business card is a good way to spread this out too. Another trick to do is take the spreader and cut little teeth in it, like a guy that would be doing linoleum, so he could get the glue on. I want to leave a decent amount of epoxy on here. The idea isn't to try to eliminate all the epoxy. I want to leave some of it on there. Now this ship has an inset tank. In other words, the tank rides inside the wing by 2.5 inches, so we want that area to be real strong. I don't want to have that weak. So what I do, I press this down now on a sheet of balsa and then pull it up and see what kind of a bond I've got. And I can see that I've missed quite a few spots. Now I can get at the balsa. Now if you were to just do this without pulling it up and looking, that'd be that many spots that you wouldn't have any epoxy on. We want a nice thin layer on the whole deal. Nice smooth thin layer. Okay, same thing with this. Now I use 16th plywood. There's people that use 32nd and get away with it. My suggestion is you use 16th even on a Magnum type plane, a smaller plane. It's good insurance. If the plane's going to last more than one season, you'll be glad you have that plywood in there. And if you're building planes that don't last the whole season or the noses fall off, well, just make the most of what you have. Now I've got a nice press down on that. Now a little bit of alcohol right now. Take a can of alcohol, a little bit on a rag, clean off the epoxy that's dripping and drooling out the sides. I've known some people that say you can thin the epoxy and get away with the same thing. I don't like to thin it. What I've done is taken planes that are 5 and 7 years old, and when they've been to the point where I can do an anatomy on them, I like to see how tight those doublers are, and those doublers really are good. They really do hold up well with this method. Again, if you're trying to build an ultralight airplane, maybe you'll want to try 32nd. This plane's going to have 16. Now I'm pressing this up against my true block to get a true top edge. In fact, I'll do it on the table too. Get out all the drippy, drooly epoxy wherever I can. Okay, that should be one side ready to go. Once this dries, we'll center line this guy all up, and we'll be in good shape. Just put something heavy out here. Okay, reap that dusting, baby. Okay, we're just going to repeat the same thing on this side. Spreading that epoxy out with the trowel. Try to get enough on there that you can use both fuse sides. Now, if you were kind of in a rush to get going, if you had limited amount of time, it helps to hit this with a hairdryer a little bit. Don't boil it. Give it a little shot with the hairdryer. That'll help kick off the epoxy, much like Kicker does with hot stuff. Now, because this ship will have rubber mounts, I'm thinking maybe I can get away with a little bit lighter construction. Normally, if this was a normal 60 ship, I'd be trying to make this like a brick shithouse up here. Eat up some of that 60 vibration. A little insurance policy if you ever nick a prop or have a lean run that you don't eat up the nose of the plane. Boy, there's been a lot of 60 ships that the noses have fallen off. Okay, we're just going to pull this up now, like we did before. And what I'm doing is troweling this right down into the grain of the wood. Shove that glue right down into the grain. Give us a real good bond. Again, keep in mind, this is not a piece of 4-pound wood or anything here. This is a piece of probably 8-pound wood. It's got real nice straight grain going through it. If you can get a piece of real nice straight sea grain, that's your first choice always. That sea grain is make a much better fuselage. It's getting harder and harder to get good balsa wood too. You got to get it when you can. Now once we get these two guys glued up, and we're real happy with the way they work, I got the alcohol to pull out the ooze. We'll do a little sanding on them. We'll bevel down the edge where the doubler ends to avoid making a stress riser there. We'll put a 45-degree bend with the Dremel tool. I'll put that on a video if I don't forget. Keep in mind when you're designing up a fuselage, you don't want anything to end right in a hurry. You'd like to have it that it was a constant taper. It wasn't a step where all the vibration will settle in and put a crack in your body. Usually that happens right on a typical Magnum, right under the wing where the cowling ends. That's a stress riser. You'd like to have it a constant taper if you had a choice, but since you have to work with the materials at hand, about the only thing you can do is put a nice bevel in the end of the doubler after it's glued on. Okay, and get epoxy off your hand before it kicks off. True this guy up. Yeah, she's pretty true. The more of this crap you can get off now, it's less sanding to do later. While this is drying, we'll try to make up some of the plywood formers and all the paraphernalia for the rubber mount. Get the epoxy off the trowels before it dries. Make sure we didn't make one left and one right. Nope. Wow, miracle of miracles. Get rid of the extra epoxy. We just did this about perfect. The epoxy's just starting to kick off. It won't be real hard for about an hour, so we've got an hour to work. We'll make up some of the formers for the rubber mounts. Try to put some of that on a video too. Now this is the bag. I've saved all the parts from the rubber mounts. It's grommets that are made by a company called Vibradamp. it's a bunch of hardware. I've made up 2 bulkheads. I made these up the other day. This is the part that's actually, I'm going to machine this out of aluminum down the shop. This is going to mount to the back of the motor. These are just templates for making up more of these. And this is actually the mount that's going to go, the firewall is going to go in the plane that's going to hold the engine. The rubber grommets are going to bolt to the front of this. This piece will bolt to here, and the motor will bolt to this. So this will all be rubber mounted like board mounts. This piece will go in the nose of the plane, or I'll make my own out of plywood, put the rubber extension on it. I'm not going to use these little ears. They give you little plastic ears. I don't like that. That's why I'm making a substitute is going to be this part here. I'm not going to use that. I'm not going to use any of the little hardware either. I'm going to get industrial quality hardware. So, again, this is a vibradamp that's made for 60s. We're going to use it on a 46. The instructions are pretty clear if you're interested. But you must radial mount it. And what this allows me to do is mount the engine sideways. And I'm hoping I'm going to be able to, if I really have to change the vertical CG, move the motor to straight up and down position like a normal inverted mount motor. The idea of that would be, if the vertical CG was off, or if I wanted to just see how the motor ran, I could run it without the cowling on and just change the header for the engine. Since the pipe stays in the body, that's going to be a real convenient way of doing it. A lot of thought went into engineering up this nose, and I hope my plans are going to look like the finished product. I'm not going to have a tremendous disappointment when I go to fly this thing, but of course we'll find out. Again, I haven't built a radial mount engine plane yet. This is the first one, so I'm trying to, if anything, over-engineer it a little bit. Not take a chance that it's going to self-destruct or anything. The next one probably could be wider. I made this bulkhead out of 10 sheets of 64th plywood. The reason for that is I have tremendous amount of laminations in it then. This is really rigid. There's no way this is going to break. A piece of 1/8" plywood scared me, just holding a motor onto 1/8" plywood, yet I've heard that you can do that and get away with it. This is about 5 grams heavier than a piece of 1/8" plywood, and I'll just not take the chance on this plane. I'm going to put a lot of time into finishing. I don't want to take a chance it's going to fall apart. Alright, so I'm going to have to make up a second bulkhead for the back of the plane now. I'll make that out of light ply, a duplicate of this, and then we'll be ready to go. We're ready to start gluing this body together. Now if you notice how I'm cutting this bulkhead out of the piece of plywood, what this will allow, this is 1/8" light ply, this will allow the grain to go corner to corner. Whenever you make plywood bulkheads, you like to have the grain going corner to corner. That's the way you'll get the maximum strength, rather than cutting it the other way. This way you've got strength going corner to corner. This is the proper way to make a piece of plywood when you're trying to make a stressed former. This is the former that goes at the end of the tank box. The one I made out of 10 sheets of 64th, I have each lamination going in a different direction, so that wood then becomes almost like a solid piece of fiberglass. Gives it a lot of extra strength when you do it this way. Corner to corner, you want to connect the corners anytime you make any bulkheads, especially out of light ply because it's not that strong to begin with. What I'm trying to do is make a mirror image of one to the other, true it up, get the last few thousandths off with a sanding block. You can feel when you've got it real accurate. Again, I've got the plywood with the corners connected for maximum strength, maximum vibration dampening. Keep in mind, I always build my planes as if they're going to last forever. I don't make disposable airplanes. Might be able to use, say, 3/32 plywood here if you were going to run the risk of maybe only getting one season out of the plane. Now I've got a perfect mirror image out of the 1/8" ply. This is F2, this is F1. This will be my tank box. Now I always seal up all the edges after this is final sanded. I seal up the edges of the plywood with thin hot stuff. Because I'm going to hot stuff these bulkheads in. And if you don't do this, what happens is all the hot stuff runs in there, and then you, of course it always runs down onto your pant leg. You don't get the complete strength of the joint. I just hit the edges, then I'll go back and sand it out. Try to use the minimum amount of kicker, which I'm not going to have a choice because I don't have any more kicker left. Good old kicker. Okay, let's get another thing of kicker here. Okay. Always try to use a minimum amount of kicker on the hot stuff. Don't bury it in kicker. The kicker makes the joint brittle. Go back and sand the edges smooth. And you've got a nice, hopefully a nice sealed piece of plywood here. The grain going corner to corners, nice smooth surface, so when you go to fuel-proof this part of the plane, it doesn't soak up a whole bunch of dope. The smoother you can make the surface, within reason, the less dope it's going to soak up, or epoxy, or whatever you're going to use to fuel-proof the tank compartment. Now, one of the nice things about tune pipe planes is they usually don't get soaked with as much oil as normal planes. But you still have to have them fuel-proof in the event you get a tank leak or a piece of tubing jumps off the tank or something. This will ensure, again, that the plane will last forever. Planes will probably outlive me. I'll be dead and these things will be flying all over the country. Okay, I did the same thing on this off camera too. So we've got the two formers, got the rubber grommets, that's drying up. Should be ready to assemble a fuselage in a few minutes. Maybe I'll take a lunch break now. Now these doubles been drying for a little while. They're still not completely cured off, so what I'm going to do is hit them with a hairdryer. Speed up the drying. Now, another thing this hairdryer deal does, it thins out the epoxy a certain amount. Better bond. Usually I blow the fuse whenever I do this, so if the light's still black, you'll know what happened. When these are dry, we want to get the center line on, of course. The other thing we want to do is seal all the edges with hot stuff so fuel can't get in there in case we have a tank leak or some kind of a problem inside the plane. I don't want this thing starting to fall apart from the inside out. Cheap insurance. That really does thin out, ooh, that's hot. That really does thin out the epoxy. Give us a little bit better bond here. I missed one spot when I cleaned these up. Okay, we're going to try to put a little bit of a taper in the end of those plywood doubles. Okay, the idea of that is it tries to eliminate having a stress riser right at where the doubler ends. You want to make a nice smooth taper joint in there too if you possibly can. Where it goes from plywood to balsa, it doesn't just end like a step, it goes down like a little bit of a sliding pond. That lets the vibration transition smoothly into the fuselage side instead of ending at the doubler and trying to make a stress riser. And that's a real good idea. Now normally on a 60 ship you'd want to end the doublers about at the flat hinge line. Because these motors vibrate a little bit less and because they run smaller diameter props at higher RPM, you don't really need all that extra weight. So we're ending the doublers really about an inch past the high point of the wing. Okay, we'll put a drop of hot stuff there just to hold it in place. Keep in mind that hot stuff gives us a little bit of a ramp into the stress riser too. Rather than just ending at a flat spot, we've got a little bit of a transition into hardwood. You really don't want to just end the doubler. That's what you don't want to do, because where it ends is going to be the point in any kind of a stress situation where it'll either crack or where you're going to get your vibration. Now we've got this pretty well sanded out. Got the fuselage sides matched up, cleaned up, sanded out. Got them pretty even, they're pretty straight. Now the next job we want to do is to get a center line on this. And what I do is I take a tri-square and I drill a hole the distance I want the center line to be, which I've already done on a plywood template, so I know exactly where this should be. Try to get a nice even center line on this because I'm going to use this center line to line up my wing, center line of the wing, the tank box, this becomes a critical part of the plane when you go to line it up. I also want to get a center line on the inside of the fuselage too. This will allow me to line up the fuel tank, anything I have to on the front of the airplane. This will be a good center line. Again, the Nobler video really goes into real detail about how to use center lines. It's a real handy thing to have. Okay, and that's a good way to put on a center line. You can get these tri-squares in any drafting supply store for about $2. Then just drill a hole the size of a ballpoint pen, the dimension you want the center line to be with. Again, we're going to work off of this center line. Now this engine is mounted on the same center line as the wing on this ship. So this will be a handy reference. Use this for both. I always go way past the flap hinge line, way past the end of the flap, because I'm going to line up that flap. When that flap is in neutral, I'll want this to be in neutral too. Go well well beyond this way. Even if you lose the center line through sanding, you can pick it up again. Okay, so we have the center line on both sides now to work with. Now I'm going to put a little piece of carbon fiber right in the top of this fuselage where this joint is. This will just keep the joint from cracking if we really do have a problem. Let's hope we don't have a problem either. This will also keep it from breaking if during construction we manhandle it a little bit. I'm just using hot stuff to hold this down. Dave Brown makes this in smaller amounts, so you don't have to buy a $400 roll like I did. George Spar at Aerospace Composites can also get you small amounts of this. And this is good material to use. I'm going to try not to get little splinters of this when you're using it. That'll ensure that that doesn't break. Again, we're trying to avoid having any spot on the fuselage where the plywood or the carbon or whatever ends. We want to kind of make them all at uneven amounts so that we don't get that old bugaboo to stress riser. Okay, that's what that looks like, and we'll do the other one off camera. Well, we're cleaning up the table real good now. Get all little dots of hot stuff off. Cleaning it up with alcohol because we're going to do the fuselage alignment. I don't want to have little dots and stuff all over the table. Any little hot stuff dots, you go off with a razor blade. And boy, they are all over the place. Okay, what we're going to do is do the alignment on the bulkhead. Remember, this is a radial mount plane. The way we'll make sure that we have 90 degrees is we'll draw this in. First I go up to my plans. Make sure I got a full 90 degrees drawn in here. So now I'll use the front line on this as my alignment gauge. Same thing with the other side. And we got the edges of that all evened out now. And we want to measure. Let's see what I did on my calculation here for the front plywood was 6 here. Front edge. Try to get this guy in here at exactly 90 degrees, of course. Now we can kind of mirror this up. So we have good alignment. Make sure everything's at 90 degrees. Reverse it both ways, that minimizes the error. Okay. I want to get one side of this at 90 degrees, the other side at 90 degrees. Triangle. We're just tack gluing this together until we can get everything lined up right. I'm using the fuselage top side to get a start on this alignment. This will just be a tack glue. this and put triangle gussets in there. Make sure we get this nice and straight. And the idea of tack glue, and this is a little crooked when we trick it with our triangle, we can just break it apart and do it over. Before we put the front one in, we'll tack glue the back together too. One drop here will hold this guy together. Okay, now we're starting to form up what looks like a crutch. Nice and straight that way. Make sure we don't have any crooked stuff here. Okay. Using those lines, or pen lines I put on there, I'll try to get this guy at 90 degrees. Okay, now we'll obviously just have this tacked in here for now. Let's get this table cleaned up. You gotta keep getting rid of the dots of hot stuff or else they keep chewing up the vaulted fuselage sides. Okay, we'll look at the alignment here and we'll see what this looks like. Check that everything's in at 90 degrees. Oh yeah. I want a little bit of motor offset in here. There's two ways I can do this. I can build this fuselage real straight and then put washers under the rubber mounts, or I can offset the bulkhead, and I think I want to offset the bulkhead a little bit. That looks pretty good at 90. Now see, I don't have this straight, so I'm going to feel good about breaking this off. Now we know we've got the 90 degree. Okay, we've got that 90 degree. We've got this 90 degree. Now we want to put in some offset. Put in that tiny bit there. Okay, that looks pretty good. Now we got everything lined up pretty well. We're just trying to get the hot stuff joints nice and smooth. Now we'll put a permanent joint in there. A little bit of sanding, get them nice and smooth. Soak them with hot stuff. Hit them with a Q-tip. The Q-tip's just to rub it in. That'll pick it right off. Try to get each corner the same way. Try to run some hot stuff down the corner. Take a new Q-tip and just rub it in. This is a good trick. Do this on all your formers. This is thin hot stuff. And you'll see the Q-tips will even help kick it off. As I put the formers in, I'll take each one and do this. Just rub that hot stuff right in, put a little pressure on it, catch the drips as they come out, put a little squeeze on it. Maybe a drop of kicker here would be a good idea. Then I like to go back and sand that joint. A little piece of sandpaper wrapped on there because I'm going to triangulate this. This is going to be a pretty stressed member. He's going to hold the whole motor in place. If you run that hot stuff right down with a Q-tips, you're going to find out you're going to get real nice joints, look real professional, no extra work. You won't have drips and drools all over the plane. Just say to yourself as you do this, Q-tips are cheap. Now I can get in there with my piece of balsa wood now and hit that joint a little bit. Try to hold that up by the camera, I don't know if you can see that. I'll try to sand each one of the joints a little bit now. And then I'll go back over them with the hot stuff again, build up a little filler. And then I'm going to make myself some little spruce triangles to fit in there. Spruce is a real good choice of material to do that with. real good one to use on a lot of joints. It gets a nice even fillet of the CA in there. And it's just something in the cotton that helps kick off the hot stuff, so you really win both ways. Before I triangulate this, I want to get a nice bead of CA everywhere. Okay, so we have the firewall in there. I put the little tail post in. I don't know if you can see that. Of course, I got plenty of hot stuff all over my hands right now. Everything's getting sloppy. Clean this up. And I'm keeping that down on the table to make sure I keep it good and straight. Clean up the table right now and check before I do the gussets that I haven't made some misalignment in that. I'll double check all the alignments with the old triangle. Okay, I got all the little gussets in around the plywood here. Gussets front and back on everything. The 1/4 inch square spruce, I'm going to take the Dremel tool and round the edges off a little bit, so we'll have complete radiuses everywhere. Then I'll sand everything out, go over the hot stuff joints again, and we'll be ready to put the back formers in. Radiusing off the edges of all these 1/4 inch square spruce braces. I'll put in here with a little dowel. They start off square and they wind up with a radius on them. Shaft is a good diameter for this. triangulating all these corners is an important part of getting this to be as strong as it possibly can without being too heavy. Even though this takes quite a bit of time, it's definitely worth it. And we'll get in there with the Q-tips again and get all the joints nice and solid. Spruce is a real good material for this. It's nice and strong and it's not really a lot heavier than balsa wood. It makes a good joint. We've been working on this about 6 hours already, and we've got the bones of the body shaped up, so we're not in bad shape. I get quite a bit of this done today. Okay, and all those, everything has a nice radius on it now. We'll get over that with the hot stuff again. Point where we're going to make the tank box floor. I've laid that over there and traced it out. Now I'm doing it with 16th balsa, and I'm going to sheet it with 64th plywood once I get the fit pretty good, so that the plywood will face in at the fuel tank, give it a little more support, plus it'll be a little more fuel proof than just having raw balsa. I also have the grain of the wood connecting the corners just like I did with the light ply. We have corner connectors, grain going corner to corner. I glued up 2 pieces of 16 sheet so that I could do this in one piece. Sometimes you don't get this right on the first shot. You have to make 2 or 3 of them up to do it. This might be the case with this one. If it is, we'll try to glue it with the grain end grain again. So it'll be like plywood, end grain plywood, end grain balsa. Okay, that looks pretty decent. And that's how that's going to go in there. That's going to be the tank wall. Okay. We'll get a piece of 64th plywood and connect that all up. And remember, the plywood has grain this way and it's strong this way. So we want this grain going side to side. So that's the way we want that to go. Now remember, we'll have the grain facing in, plywood grain facing in. That'll be for shimming the tank. It'll be a little bit stronger. Maybe we'll double up on a 16th ply when I see how tight this is. plywood usually has strength because it's 3 lamination. It usually has strength in one direction, and you want to take advantage of that strength. You don't want to just give that up for free. We can put the same radius on the corners with this tool. So we're going to try to get a nice tight fit in here. This is actually going to do a lot of the work of keeping this tank box rigid. Let's see what kind of fit we get. That's why it's always a good idea to make these points a little bit oversized, and you keep it sanding until you get a nice tight fit. You wind up using less glue that way too. You get a better wood fit. I'll just keep grinding away at this until we get a real nice fit. I want to get a nice tight glue fit. That's also going to seal the rest of the airplane if we get a tank leak or any kind of problem like that. So a little bit of time and effort now should pay off in the future. Especially as the years and you get up in the 2,000 flight area, planes don't fall apart. They tend to stay together. Okay, we've got a pretty good fit here now. Kind of dress this off a little. do this, leave the dust on too. Just leave the dust right on the part. That helps kick off the hot stuff. Okay, now we got a nice press fit, that press right in there. You seal up the back, drop it and break it. Okay, we'll seal this up. All I'm going to do is get a piece of wax paper under it so the hot stuff don't leak all over the table. We got all the braces around the firewall, all the braces around the back. This is all sealed up nice now. Sealed up on the top nice. Just rolling some hot stuff around in there, make sure we got all the corners covered. That's a nice rigid box nose now, that's good and solid. Alright, we're going to start putting the fuse formers in next. Now what we're going to do now is put a floor in the middle of the crutch, and what this will be to isolate the pipe from the rest of the fuselage. Give us a floor to mount all our formers to also. Hope this will stiffen it up a bit too. I made a little balsa template for this. Transposed the curve onto the other side so I have the identical curve on both sides. Now I just want to see how far back I want this to go. This is the part that'll probably be different on every plane. It's built for a tuned pipe. You have to figure a way of getting at your hardware and isolating that pipe from the rest of the body. You need a pipe mount behind the center of gravity. You have to make some kind of access to get in there and take the pipe in and out. I'm going to try to do this in a way pretty similar to what Billy Werwich did, where he shoves the pipe in through the front and it's just a big access hole you can get at things. This way you leave a lot of the bottom block attached to the plane. It strengthens it a little bit that way. try to put this on an angle that will give me the most strength. I think that kind of an angle will be the best. We'll add some strength in it, I hope. Okay. And what I'm going to do now is put my 16th sheet on a 30-degree angle on this. And this will be balsa plywood. Again, everything's on a 30-degree angle. Just kind of connect the dot. Works pretty good on this, stiffening it up. You'll be amazed how stiff this gets. Okay, now that's the way the double grain goes on there. Now right at the very end I put the grain sideways. That gives me the most strength that way. Right on the ends you just want a dead cross grain. This is a good way to do it, even if you're going to sheet the bottom of your airplane. Just plain sheet the bottom. Put the grain on a 30-degree angle. Make it geodetic. It'll be a lot stiffer that way than if you just run a piece of sheeting across the bottom, 1/4 inch or so. You can get the same strength as 1/4 inch by using maybe even 1/16 if you do it with the grain on a 30-degree angle. I'll just go right down this sheet. This is really a nice way to build strength without adding a lot of weight. If you're looking at really do a high-tech job, this is really a super way to do it. Alright, I'll do the rest of this off camera and then we'll get to putting it in. Now I'm just tacking this in to get it even. Do one side at a time. And at 3/4. Now this bottom piece has a little bit of a curve in it. A curve will always add a little more strength than just making it flat. And it'll let the air get out the back of the airplane a little smoother too. So I'm just going to go down the block here, tacking it in. When I get it right, I'll just sew it right up. 7/8. Remember, I got that grain at a 30-degree angle, so that's giving me a little more strength than just doing this at random. Okay, and we got that tacked in now. Okay. Now we're going to try to get a seam glued right along the edge. This is one way to get a nice joint, is just let it run down. Again, I like to take the Q-tips and get myself a nice fillet of CA in there. This always works. Gives it a nice clean appearance too. We can turn this guy over and start it real fuselage form. We can look right down it and see that you got a nice curve on both sides. Try to keep the body wide in the back, don't get it too skinny. Make it a little bit stronger than it normally would be. Allow us enough room for the tail wheel now. Okay, now we're just going to drop fuselage formers in there. And we're pretty much finished with that crutch for today. When you do geodetic formers, which means that they're on a 30-degree angle, You have to hand fit each one individually. I didn't plan on doing geodetic until the very minute, a minute ago, when I decided to just add this final touch to this. Geodetic formers will always be a little bit stronger, make the back end of the plane. Because I'm going to have the bottom of this plane semi-removable and have a big hole in it, I want to stiffen it up as much as possible. And this is a good way to stiffen it up without adding weight. You got to hand fit each one because each one is a little bit bigger in the front than it is in the back. Kind of time consuming, but when you're done, you'll have something special. Anything geodetic. In other words, anytime you can make a triangle instead of a square, you're going to add strength to a structure. Triangles are the strongest shape you can make, and squares are about the weakest. So we try to triangle this up as much as possible. Again, I roll the glue around. And you just have to work your way right down the fuselage, making yourself these 30-degree formers. What I do, I try to get the shape I'm looking for at the highest point first, mark that out, mark it parallel, and then sand about, I guess a 64th off each side. This gives me the basic shape at the biggest point, and I try to just rough estimate how much it's going to be to take off. And of course you got to take the same amount off each side. It's nice if you can use some nice C-grain 16th. Now the formers, when you do them this way, need only be 16th. You don't need 1/8" formers. And when you're done, the structure will be a lot stronger than if you use 1/8" formers and don't geodetic it. Anytime you can, and you can turn your structural shapes into triangles instead of squares, you're going to be way ahead of the game, that's for sure. And this one I've made too thin, so I have to get 1/8" bigger on the top. And usually you wind up making these over and over and over until you get them right. That's not unusual. Each one is a custom fit deal. Sand one down like I just did and make it too small, just use it for the next station down. You get a real good feel for doing this. It won't take you long to pick up the whole technique for this. Again, we like them to be as tight as possible. The fit, we don't want any extra glue or slop in the fits, if we can help it. down that you're not bowing out the sides of the fuselage. Okay. Nice and tight. The angle in the bottom so it butts up against the bottom sheet on a 30-degree angle. If I can get it that way, yes sir, I can. Get the glue on the back side of the seam too. Okay, I'll finish this off camera to save tape, and we'll be almost finished today. This is going quicker than I thought. Alright, we've got all the formers in now. All geodetic, of course. And we're just going to put a nice little glue seam on every one of them with a Q-tip if we can. Now most of this is going to get cut away when we make the push rod hole, but for now this is fine. Now this geodetic formers in the back. If you've ever built a ship this way, you know how strong this is. This is like a free flight, a rubber powered plane. They're just super strong. All 16th formers, no reason to make them anything bigger than 16th. Put that hot stuff in there. Okay. Now what I did, I got the final gussets in up here so we don't have a stress riser. Notice it changes shape, down, down. Just brace this up so while we're carving the blocks, we've got the bottom already in, 30-degree sheeted. Bulkheads are all triangulated. Now what I want to do, I'm going down to the machine shop tomorrow. We have a nice saw down there. I'm going to just rough out the top block. So I'm going to measure out my dimensions for the top block. I got a real nice block here to carve. It's got a little bit of a warp in it, but that won't matter. It's a super nice white piece of wood. Okay, so I'm going to measure this out now. I want to see how much I want to have for a top block. I think I want 3/4 of an inch. Over to my diagram here. Three-quarters of an inch. Okay. So it'll be 3/4 of an inch on the top and 1 1/4 on the bottom. You got one at 3/4 of an inch here. Now because we got a warped block, we're going to try to put a straight cut in this block. You can kind of get the taper in there too. Okay. And this way we're going to get the whole top block out of one block. We hope. In this last one. And we'll use the cut surface then. We don't want to wind up with a fuselage that looks like a watermelon. Like a guppy or something. So, okay. So now I'll cut this out on a bandsaw. And I'll want to get this piece in the front. Top block, this will be the bottom block. Okay. Okay, we'll be able to get it all. Okay, and what we'll do, we'll get this dimension on here. Roughly where this is going to be, we got the bottom 3/4, the bottom is 1 1/4 and the top is 3/4, and this way, even if we have a warped block, which is what this is, it's not a problem, because we've got a straight line. We're going to cut this straight. Okay. And we can also cut the top shape out. We have this here. Well, I kind of slant it off to one side if I can, and then I can use that other piece for the tail piece. Okay. This way I'm cutting the top block and the bottom block at the same time. Now when you do this, the one thing you got to remember, you must cut the block in half first. If you don't cut the block in half first, in fact I'll make a notation on it in case I'm tired tomorrow. I went through about 15 blocks to get this piece. This is a real nice piece. This whole block is a 2 by 3 by 36. Only weighs 9.5 ounces. That's a real good weight for this size block. That's about, I'm guessing, under 5-pound wood. I'll just get this doubly in there. Got a real nice bandsaw, and that's handy to have. If you don't, of course, then you've got to cut this. In the past, I've cut it with a coping saw. That works okay. Or set up the Dremel if you can fit the Dremel in there. Okay, we've got everything now. Okay, that's ready to cut. Now the other thing I can make today is the tail wheel mount. The tail wheel mount I try to always get right under the horn on a 30-degree angle so it stiffens up this part of the body. And I want that horn, I want that plywood on a 30-degree angle, and I want to interconnect it with this. I don't want to glue it in permanently at this time, but I'll make it up right now. And I'll probably have to make 7 or 8 of these. Again, remember this plywood has no strength this way, strength this way, 16th plywood. So we obviously want the strength to be this way. I'll just make up a little pattern here. See if I can get this. Try to keep the tail wheel reasonably light. I'll make it 1.5 pounds. Okay, on the old Dremel saw. I'm marking off the spot on a 30-degree angle here for the tail wheel mount. Since I always use a real thin, small, short tail wheel, I don't have to really make this too beefy. If I was going to make a normal, I call it normal, a tail wheel sort of plain set level, well then you better make this out of 1/8" plywood and 3/32 wire. But for this guy, 16th wire will be plenty good. We're going to have a relatively short tail wheel. We want to get this in on a 30-degree angle so it'll play as much of a role for stiffening up the fuselage as possible. Make it a nice tight fit too. Okay, that should be good. Now we'll bend up the wire, get this sorted, sand it a little bit. Get the wire bent up and then we'll thread it on just like you would tying your shoes. That wire tied to this piece. We'll leave enough wire hanging out so we can bend it after the plane is finished. I don't like finishing around a tail wheel. I leave it straight until the plane is actually finished, and I make the final bend. Makes it a little bit easier. Okay. So again, that's going to slip right in. 30-degree angle. Perfect.
Okay, I've got the wire bent.